What is up, everybody? We got another one for you here on the Mathnasium this morning. And by that, I mean we got another YouTube video, math lesson. But I also mean we got another sinus infection here on the YouTube channel. So apologize if I'm sounding a little funny this morning. That's okay. Wouldn't be the first. Let's jump right in to Algebra 1's Unit 2 review. Now, Unit 2 was about kind of graphing linear equations. So there are a lot of examples here, but I want to make sure I cover everything and make sure you guys are feeling good. And then I'm going to move kind of fast. Feel free to pause, rewind, do what you need to view things more than once. Let's jump right in with our first example. Make sure I have my notes pulled up here. All right, so the first thing we're talking about is slope. And I have the section number, so if you want, I should have done this in the first video. You can go back and look at the section number that this was in. So this is in 2-1. We're going to do everything kind of in order in the unit. The first thing that we learned about were the 4 types of slope. Slope falls into 4 categories. Those categories are positive slope. Positive slope is anything that has kind of an uphill slope, like this. Okay, like that would be positive. Anything that's very steep, it doesn't matter where the line crosses, it matters how it's slanted, right? Even this down here, if it's very gradually uphill, this is still considered positive slope. Negative slope, as we go from left to right, is going in a downhill manner like this. So this is what negative slope looks like. As you go from left to right, it looks like you're biking downhill. Could also look like this. But I could keep drawing a billion of them. So if it goes downhill at all, we consider that negative slope. All right, down here, zero slope. Zero slope is the third category, and it is when you have a completely flat line like this. Horizontal lines like this typically have their equation is like y equals 4 or y equals -2 or something along those lines. So this is zero slope. And then lastly, we have lines with undefined slope. When you do the slope calculation on these, remember you end up dividing by 0. 0 is in the denominator, 0 is in the numerator with these. So let's take a look. Coming down like this. Okay, undefined slope is when you have a vertical line. So this is like x equals -6 or something like that. Vertical line. Those are the 4 categories of slope. Okay. First off, let's find the slope between each pair of points. Looks like my points got erased here, so we're going to have to put those back on here as point number 1. That is the point, -5, -1. Point number 2 is 7, -5, which is right here. So really quickly, remember slope has many representations. You've heard me say rise over run many times. It's rise over run. And that's the one that we're going to be using for this example. So rise over run, we need to figure out how far did I go down or up, depending on your perspective, to get from this point to this point. I went from -1 down to -5, 1, 2, 3, 4. In this case, I went down 4. Okay, what's my run? My run is this direction here. I started at -5, and then I end up at 7. So from -5 to 0 is 5. From 0 to 7 is 7. 5 plus 7 is 12. So I went down 4 over 12 in this instance. And I have, yeah, this should be fine. Okay, so this is the slope between my 2 points. Now I can see the line that connects these is sloping downhill. It looks like the negative option. So my slope is -4 over 12. But of course we're not done, because -4 over 12 is not simplified. Both 4 and 12 are divisible by 4. So this has a final slope of -1 over 3. Your final slope there, -1 over 3. Okay, what if I give you a line like this, or 2 points like this, and there's no graph, and I say, or maybe the numbers are really big, and you have to calculate, and you can't use a graph paper. Well, there's another formula for slope, not just rise over run. The other one is y2 minus y1 over x2 minus x1. Okay, and when we were writing these, remember the strategy that I gave you was to put a minus sign right here and then put in 4 empty sets of parentheses and then just start plugging stuff in. We'll call this point 1 and point 2. In that case, y2 would be -2, y1 would be -10. X2 would be the 6, and x1 would be the -6, which is equal to, cleanup step, this is -2 plus 10 minus a -10 divided by 6 minus -6 is 6 plus 6. So our final ratio here for our slope, our rise over our run, is equal to -2 plus 10 is 8, and 6 plus 6 is 12. Both 8 and 12 are divisible by 4. 4 goes into 8 twice, 4 goes into 12 3 times. So your final slope of this line is 2/3. Okay, last slide from 2-1, I think. Can you find the slope of this line? If I give you a question like this, basically you just need to find 2 points that are next to each other that it looks like it travels through. Looks like it travels through this one. It doesn't quite travel through that one. And it looks like it travels through this one. So find 2 points that are close where it travels through the grid lines. And you can count. It doesn't have to be on the bottom. Looks like our slope is negative here. So I'd say m equals negative something over something. What's my rise? What is my vertical change? That is this distance. That's 1, 2, 3, 4, 5 squares. What is my run? That is this distance, which is 3. So my slope is -5/3. Okay, now we move on to 2-2, which is graphing lines. The first skill that I think lots of people are good at this, so I'm not going to spend a whole lot of time. The first skill that you need to know is to be able to identify the slope and the y-intercept. Now the slope is always the number that is the coefficient of the x term. So what number is out front of the x, or rather, kind of how many x's do we have, so to speak. The coefficient of the number out front, in this case, is, there's nothing written, so our slope is 1. Our constant term is our y-intercept, which is where our line crosses the y-axis. In this case, that is -7. So if I want to graph this line, I go to the y-axis, and I always start with my y-intercept down at -7, and I have a slope of 1. What is 1 as a fraction? We can write it as 1 over 1. We can write it as -6 over -6. We can write it as my personal favorite, which is 2 over 2. 2 over 2, I'm going to go up 2 over 2, and I'm going to repeat that across my graph. Oh boy, here we go. All right. And then we have our line there. I'm going to try and connect these as best I can. There we have our line y equals x minus 7. That was fun. Okay. I lost my notes. Let's move on to the next one. I did also teach you that there are kind of multiple ways, strategies for graphing something that looks like this. Now this is standard form, or something close to, where you have the x and y term on the left and you have your constant on the right. So what are the 2 methods we have for graphing something like this? Well, the first method, so we'll call this method 1, or way 1. Okay, the first way to do this is to force slope-intercept form. So I have -9x plus 6y equals 48. I'm going to add 9x to both sides. You end up with 6y equals 9x plus 48. I think you guys are pretty good at this tactic. So you force it into slope-intercept form. We're going to divide both sides by -6. So divide this by -6. Let's change my colors here. divide by negative 6, divide by, sorry, not negative 6, we're going to divide by positive 6. 6 divided by 6 is that 1, my coefficient of 1. 9 over 6 is actually 3 over 2, if we simplify that fraction. And then 48 over 6 is plus 8. This is nice. Yeah, this is good. Okay, y-intercept of 8, like this. And then I have a rise. My slope is 3 over 2. So I'm going to go down 3 over 2, down 3 over 2, down 3 over 2, all the way across my graph. And there we have our line in about as good of a form as I'm going to be able to get with my laggy computer. All right, cool. Way number 2. Way 2 was kind of to find the x and y intercepts. And we can already see the y-intercept, but if you had done this method, it's just fine. So to find the y-intercept, let's say we didn't have any of the green work done. You plug in x equals 0. And when you plug in x equals 0, you end up getting negative 9 times 0, which is just 6y equals 48. And y equals 8. Divide by 6. So you have the y-intercept of 8. This is one method, okay? And then you can also do the same thing with the x-intercept. The x-intercept is where y equals 0. Okay, when you plug that in, 6 times 0 is 0, and you just end up with negative 9 x equals 48. When you divide both sides by negative 9, well, 45, you're going to get a negative number, first of all. Negative divided by positive. Okay, and then 9, you can subtract from 48 5 times, and there's 3 left over, so that's negative 5 1/3. We can see that is roughly where our line crosses. So way 2 is you find the x and y intercepts just by doing 2 quick division problems, and then connect those with a ruler. And that's what we learned in 2-3. Okay. In 2-4, this says, write the equation of a line in slope-intercept form that passes through negative 3, 4, with a slope of negative 6. So in this lesson, we used slope-intercept form. So we always start with y equals mx plus b. I forgot to mention, during the video, you should be jotting stuff down on your note card that you can use on the final. Okay, step 1 was to plug in the slope. That's y equals negative 6x plus b. Okay. The next step is to plug in the point. So this basically says I need my slope to have I need my line to have slope negative 6, and I need it to pass through this point. So we plug in 4 for y. We plug in negative 3 for x, and then all we do is solve for b to figure out what the equation of our line is. So here we have negative 6 times negative 3 is positive 18. Positive 18 plus b, minus 18 from both sides, and you'll get b is equal to 4 minus 18, negative 14. Negative 14. But that's not our final answer because I said write the equation of a line in slope-intercept form. So now we're going to take the slope and the y-intercept to write our answer. That is y equals negative 6x minus 14. We're making good time. Okay, this one is a little bit different. It says write the equation of a line in slope-intercept form that passes through 6, negative 2, and negative 3, negative 8. Well, in this case, I didn't give you the slope. I just gave you 2 points. But it turns out if you have a point in the slope, that's enough information to write the equation of the line. And if you have 2 points, that's also enough information. We're going to start with that same process. What's slope-intercept form? Y equals mx plus b. Fantastic. Step 1 is still plug in the slope. The problem is we don't know the slope. So we have to do an aside. So we go off on the side and we say m equals y2 minus y1, that's negative 8 minus negative 2 over negative 3 minus 6. And when we plug those in, we're going to get, that's really negative 8 plus 2. Negative 8 plus 2 is negative 6. And negative 3 minus 6 is negative 9. So you end up with a positive. So this is negative divided by negative is a positive, both divisible by 3, 2/3. Now that we've found the slope, we can plug that in to our line, plug in the slope, that's step 1, and now it's exactly the same as that first question. We have reached a crossroads. Do we plug in this point or this point? Turns out it doesn't matter. You can plug in either and you'll get the same answer for B. The choice is up to you. I'm going to plug in this one because it's one negative number instead of 2. So negative 2 goes in for y, and then you have 2/3 of 6 plus b. Okay, 2/3 times 6. In your head, do the division first. That's always helpful, or it does not do bad. This is really 6 over 1. 2 times 6 is 12. 12 divided by 3 is 4. Okay. You can also do 6 divided by 3 is 2. 2 times 2 is 4. Either one gives you 4 as your answer there. Subtract 4 from each side and you get b is equal to negative 6. So our final answer is y equals 2/3 x minus 6. That's it. Okay. Getting close. 2-5, use point slope form to write the equation of a line that passes through negative 7, 3 with a slope of 1. All right, time to switch colors. Point slope form is not y equals mx plus b. It's y minus y1 equals m times x minus x1, where m is the slope, and this line passes through the point x1 comma y1. It's really, really simple for graphing lines and doing other stuff like that. So let's go ahead and plug in the information we have. So this is very simple to write this in point slope form. We simply take the x and y coordinates, plug them in these two locations, and plug in the slope. So this is just y minus 3 equals negative 1 times x minus negative 7. Okay, now this I would say is not simplified. You can pare it down just a little bit. The left side is fine. Y minus 3 is an okay thing for the left side. Negative 1, you can just write negative, and then x minus negative 7 is really x plus 7. And so remember with point slope form, if the point, the x coordinate is negative, it ends up being positive in the equation. If the x or y coordinate, well, it's the x or y coordinate. If the x or y coordinate is positive in the point, it ends up negative in the equation. And that's going to come in handy on this next example. Graph the line below. Y plus 3 equals 1/3 times x minus 6. Okay, so first of all, what point does this pass through? So if you see how these are opposites, negative, positive, positive, negative, I can go to my equation and say, well, what are we subtracting from x? We're subtracting 6, right? So do the opposites, negative here, positive there. What are we subtracting from y? We're subtracting negative 3. So it's positive here, ends up negative there. And here's my slope, 1/3. So when you're graphing something in point slope form, instead of starting at the y-intercept, you could put this into slope-intercept form if you want, or you just find the point that it passes through, which is 6, negative 3, and then you use that slope to get the remainder of the points on your line. Up 1/3, down 1, back 3, and we can repeat this across our graph. That wasn't too bad. And we can see here that had we done this in slope-intercept form, oops, this is going to be a tough one. Oh, I give up. I'm using the line. Look at that. It ends up blue. It's a little bit funny. Okay, whatever. So you can see that we have a y-intercept of 5. So if I were to put this into slope-intercept form, what would I do? Well, very simple. You just distribute here. So you'll end up with y plus 3 is equal to 1/3 times x is 1/3 x. 1/3 times negative 6 is minus 2. Now this is not in slope-intercept form because we have to get y by itself. So you subtract 3 from both sides and you get y equals 1/3 x minus 5. All right, you guys. That is, I made it sound like it was the end of the video. It's not. We still have 4 slides left. Sorry. There's our -5 that we just viewed from this. If you put it into slope-intercept form, you can still graph the same line. Totally fine. Whatever works for you. I find point slope comes in handy quite often. All right, great. Let's do it. Write the equation of a line that passes through 1, -2 and is perpendicular to y equals -2x plus 5. All right, so if this line has slope -2, the line, my new line that's perpendicular to this line is not going to have slope -2. To find the slope of a perpendicular line, it is opposite reciprocal, so that would be a good thing to put on your note card. So if the slope of this line is -2, do the opposite. So since it's negative, we change it to positive. And we do the reciprocal of 2. Reciprocal of 2 over 1 is 1/2. So the line that is perpendicular to this line must have a slope of 1/2. But I say that this new line must also travel through the point 1, -2. There's 2 ways to do this. I find that point slope is the easiest. So if you use point slope, which is y minus y1 equals m times x minus x1, minus y1 equals m times x minus x1. If you use this equation here, this is going to end up being y plus 2 equals 1/2 times x minus 1. Done. You're done. Write the equation. I didn't say which form it has to be in. You've satisfied everything you need with this answer here. Okay? This is if you decide to use point slope. But if you prefer slope-intercept, it's a little bit more work to write the equation of the line. We'll do the same thing we did before. Y equals mx plus b. Plug in the slope. Y equals 1/2 x plus b. Plug in your point. Our y coordinate is -2 times 1/2 times 1 plus b. It's not too hard. 1/2 times 1 is 1/2. Anything times 1 is itself. Subtract 1/2 from both sides. -2 minus 1/2. You're getting more negative, so you're really kind of joining those together. You get b equals -2.5 or -2.5. So what's the equation of the line in slope-intercept form? It's y equals 1/2 x minus 2.5. And if you go back to our point slope here, whoops, make sure everybody got that. If we go back to point slope and you distribute that 1/2, you get a -1/2 there, and then subtract 2, and you'd end up with the same thing. Okay, sweet. So both of these answers are correct. I think that point slope is a little bit faster if you like that. But we'll see. Next one. Man, I think I'm going to blow my nose. Pardon me. I'm sorry, everybody. YouTube is stealing my identity. They know what my nose blowing sounds like. I probably should have paused it so you guys didn't have to witness that. So, anyways, you're welcome. You're welcome. Write the equation of a line that passes through -4, -6, and is parallel to y equals -2x plus 5. Okay, so if my line, if the slope of this line is -2, the slope of a line parallel to this line is going to have the same slope. Parallel lines have the same slope. Okay, so if I want to write the equation of my new line, I need a line parallel to this line that travels through this point. I'm assuming you guys like slope-intercept for some reason, so I guess I'll do that. That's y equals mx plus b. We just repeat those same steps. You can pause the video and try and finish this if you'd like. See if you get the right answer. All right, here we go. Plug in the slope of my new line is -2. So -2 plus b. Plug in the point, which is -6 equals -2 times -4 plus b. Multiply those two together. You get -6 is equal to 8 plus b. Subtract 8 from both sides. B equals -14. So your final answer is y equals -2x minus 14. Okay, last question. Before we read it, I want to remind you of the general interpretations that we learned. You might not be able to see this because my face is probably in the way. The general interpretations we learned for slope-intercept form when we're talking about a word problem. Remember, so take a minute. You can take a picture of this with your phone or look back through your notes and make sure you have it, but this is what we're about to do. Okay. The question says, the cost of a house in North Pole can loosely be predicted by its square footage. Let x represent the square footage of houses in North Pole, and y represent the cost of those houses in US dollars. Okay? So here I have the typical house in North Pole, as you can see. Okay, and come down like this. That looks like a Fairbanks North Pole house right there, if I've ever seen one. It's the foliage. The foliage is what gives it away. Okay. All right, so basically, what's the picture? I have a positive y-intercept at 19,100, and I have a very steep slope. Right? Maybe it's going like that. Who knows? So here's my line. On the y-axis, we have dollars. On the x-axis, we have our x unit, which determines the cost of the house, and that is the square footage of the house. So what I'm asking you to do here is interpret the slope and y-intercept in the context of the problem. So what does that mean? So here the slope is equal to 222. Remember, oh man, the slope is equal to 222. The slope is rise over run, which is the change in y over the change in x. Now I gave you what x and y were in the problem. X is the square footage of the house and in North Pole, and y is the cost of those houses. So change in y over change in x, which means we're looking at the change in the units of y are dollars, and the units of x are square feet. All right, so if we're trying to write this in point slope form, this is going to be as follows. For every, slope intercept form. For every, this 222 is my slope right here. I stole it straight from that line. I can hear one of my kids slamming their head against the sheetrock upstairs, so I'm trying to hurry. For every, and we go back to that definition, for every 1 unit change in x, so for every additional square foot of area, so for every additional square foot of area in the house, we expect, this is really slow, it's almost easier to type, maybe. We expect, and this should be every additional square foot of area in houses in North Pole. We expect the y in context is the cost of the house. We expect the cost of the house and then we have to decide, is it increasing or decreasing? If it has positive slope, we would say that it's increasing. The cost of the house to increase by whatever the slope is, 222. And then you can put the units there, dollars. Nice. All right, that's slope. I'm going to go to the next slide because it's really laggy on this slide. We need to interpret 19,100. All right, what does 19,100 mean in the context of this problem? If B equals 19,100, okay, what that means is, go back to our interpretations, when x equals 0 in context, what was x? X was the square footage of a house in North Pole. So what this means is, if a house had no square feet, so the floor plan had no square footage, okay? It would still cost $19,100. Now, how is that possible? How is it possible that a house with no square feet would still cost $19,100? Well, in this case, that would be the price of the land on which it rests, right? It's like when you buy a house, you're buying the house and the land, so I would say this is like the cost of the land without the house. Okay, you guys, thanks for watching my video today. I had a lot of fun, and I'm sure you guys did too. I don't want any sarcastic YouTube comments there, okay? Anyways, thanks for watching. Sure appreciate it, and I hope you guys are having a good wrap up to your semester. Okay, we'll see you on Monday with a new video.